We are building the Minesweeper project from the YByte Python curriculum available at www.ybyte.in. Previously, we created a grid of buttons and we also put those buttons in a two-dimensional list called buttons. Now, we are going to move further and create one more list. This is also going to be a two-dimensional list, or let's say a list of lists. We are going to call this field. Now, this list is going to represent our minefield, and in fact this will be the backbone of all our computation going forward. Remember, when we create a two-dimensional list or a list of lists, we have to be careful that we do not create shallow copies of a single row or a single column, because we want to make sure that every item is uniquely addressable. We discussed this in detail when we looked at shallow copy during, let's say, the Connect 4 project. One method to do so, to ensure so, is to use, let's say, list comprehension, something like this. So I'm going to create, let's say, in an inner loop, 0 for, let's say, underscore in range and calls, and then for underscore in range and rows, which is basically same as setting up, let's say, a for loop, a nested for loop of this sort. We have seen this before, so we are just going to create this right now. So I just come back to my code and I create the list, let's say, called field. Like we discussed, field is equal to, say, 0 for underscore in range, let's say, and calls, because that's the inner, let's say, that's one row, and for in range and rows. Now when we run this piece of code, everything looks normal. If I look at field, it's a list of lists, everything has become 0. Now we can ensure that this is not a shallow, doesn't suffer from the shallow copy problem by just doing, say, something like this is equal to 10. And when I look at field, you notice that only one item has become 10. Now at this point of time, let me create a function again, just like we had done earlier for the in the Connect 4 project. Let me create one function here to say display field. So I'll just call it let's say, maybe I can just define the function over here, say call it def, say display field, and all that does is that for kk in range, let's say, n rows, basically I want to print every row. I just go and print, for example, field and kk. Now this helps because then I can start viewing this as like a matrix, and that is quite useful. So when I, let's say, run this piece of code, when I do, let's say, display field, you notice field is displayed quite nicely. And again, the test of, let's say, figuring out if it's a shallow copy or not, quite clearly it's not a shallow copy, because only one item has been changed here when I change this. Now, like I said, this list field will become the backbone of all our computations. Let's briefly understand what we are going to put in this list as we move forward, and then we will start populating this list. Notice field is a list of lists. Every item is accessible through two coordinates, so sort of row and column, which can be seen as x and y. If the corresponding xy location on the board or on the, let's say, minefield holds a bomb, we are going to set that value of field to 9. For every other xy location, we will store how many mines are there in this particular square's neighborhood. Now we will formally understand the concept of neighborhood definition a little bit more carefully later when we start coding this, but the idea is very clear. Basically, let's say I look at this cell, I look at all its neighbors, I just ask myself how many of these are containing, let's say, bombs, and that number I'll go and store in this cell. We will see this more carefully later. Before I wrap this up, notice that the maximum number of neighbors of any square is 8, which means that we can have 0 until 8 mines around, let's say, a particular square or particular cell, which is why setting 9 is fine, because 9 then uniquely locates a bomb. There's no confusion on this. But if you want, you can also, let's say, store some other number to represent a mine, and that's perfect. We will update the field list very carefully. It's in fact quite interesting in itself in the next few videos. I hope this was interesting. Building activities makes programming fun because it gives us a direction to move forward in. It channelizes our energy towards activity, and we understand concepts also much better. Look at our website www.ybyte.in. We learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.